We are now going to go in depth into the study of bonds, bond prices, and how interest rates get determined. So remember, bonds are tradable. Because they're tradable, they have a market price. So there is a relationship between bond prices and interest rates, and we're going to create a simple model which explains this relationship. If you look at the little picture there, actually the relationship is very simple. Everything else equal, interest rates are inversely correlated with bond prices. So just remember that inverse relationship will remain true no matter what kind of bond we're talking about, what else is going on in the world. Inverse correlation, interest rates, and bond prices. Bonds are of different types. The zero coupon bond is the very simplest type of bond. You buy it on the market for a market price, and there will be one single future payment as a result of owning the bond. A fixed payment bond is like a house mortgage. There are fixed payments, and coupon bonds we're going to talk more about. We've already talked about them somewhat already. Consols are a very rare case where a person buys a bond, they receive periodic interest payments forever, literally forever. There's no maturity date. These consols are a very old kind of financing. One thing that's true for every bond, no matter what type, is that we can arrive at a value for it by discounting the anticipated future stream of payments using an interest rate. So for example, in the case of a coupon bond, the theoretical correct price and market price should be equal to the sum of the discounted future coupon payments plus the discounted face value payment at the maturity date. So let's get how the valuation thing works. The coupon payments are given, determined by what's written on the bond, or there's some combination of something called the face value and something called the interest rate that's written on the bond, and that combination of face value and technical interest rate is simply a device to tell us what the coupon payment is. So we either get the coupon payment directly, explicitly stated, or there's this very indirect way of saying what the coupon payment will be by using a sort of a nominal face value and a thing called a nominal interest rate. Put those two things together and you get the coupon payment. So in summary, the coupon payments are fixed dollar amounts. They go into the future at predetermined times, and that's exogenous to people buying or selling the bond. It's exogenous to you or me who look at the bond. It doesn't change, and it's not something that we have to worry about. We just take it as a given fact. So coupon payments are simple. They are what they are. So we've got these exogenous, determined, outside our model variables called coupon payments. So if we've got something that's exogenous, there should be something that's endogenous, that's determined within the model. It's determined by the operation of the market. The things that are endogenous are the market price of the bond. These bonds are traded in markets. There's a market price that can be high, it can be low, it can be medium. It depends on what the traders choose to trade at. The other thing that's endogenous, in a sense, is the interest rate that the traders are using to discount the future payments. So how does this all work? Okay, imagine traders, buyers, are thinking of buying some specific bond. In their head, they have some idea about what's the appropriate I or interest rate to use to discount all the future payments. So they take that choice of interest rate, they apply it to the known future coupon payments and maturity payment. Out of that, they can calculate what they think is the true value of the bond, and that tells them the maximum price that they should be willing to pay for the bond. Of course, a trader will always be willing to pay less than the so-called true value of the bond, but they would never want to pay more. So you've got a left-hand side, the offered price, determined by the value traders have for the bond. The right side is the stream of future payments, discounted by what they think is the correct interest rate. When I say correct interest rate, what I mean is their best guess about the future interest rate. It is possible that 10 years from now, after the fact, a trader may realize the discount interest rate they were using was a bad choice. Maybe inflation went up more than they expected. But there's nothing you can do about that. A trader has to make their best guess at what they think is the correct discount I to use. Now, the person who owns a bond and wants to sell the bond is doing a similar calculation. They figure out what they think should be the correct interest rate for discounting purposes. Again, it's looking into the future. It's making some assumption about what will be future inflation. They take their best guess at what the discount I should be. They apply that to the stream of known future payments. They arrive at an estimate of the value for the bond, the price it should be traded at. Except for a seller, their estimated price or value for a bond is a floor. They will always accept a price higher than that, but a seller will never accept a price lower than what they think is the true value. So what you've got is a situation where the buyers and sellers of a bond get together, they negotiate, they arrive at some consensus agreed upon trading price, P star. The star normally means equilibrium here, just like in demand and supply. Buyers and sellers agree on a P, and once we know P, we can infer what is the equilibrium interest rate. Remember, we have an equation that has a left-hand side, a right-hand side. Once you know the left-hand side, the value for P, then everything else on the right-hand side is given except the I. So the I has to adjust to make the left-hand side and the right-hand side equal. So that's how we get the equilibrium I star. To summarize, we put buyers and sellers of a bond in the same room, they negotiate, eventually they walk out with a market price for the bond, the price it traded at. Once we see what the buyers and sellers have chosen as P star, we can figure out what I star must be. So here is the famous bond valuation equation, and this is a simple version. I'm not going to talk about more complex variations. Bond price on the left emerges from negotiations between buyers and sellers of bonds. It's a market price, just like in the demand and supply model that we study in Principles of Economics. There's a market price for a good or service determined by buying and selling. Okay, so bond price comes out of the choices of buyers and sellers once they agree on an equilibrium P star. Right hand side, once we know P star, the C's are given, the M is given, the N, the maturity date, is given. So the only thing on the right hand side that is free to adjust to make the left hand side and the right hand side equal is I. So tell me the bond price. I plug in the formula into my calculator and I know what I must be. So we've solved the equation. Finally, if you remember the little picture at the beginning where there was the interest rate and bond price moving in opposite directions, when you look at the equation, you see that everything else equal, bond prices and interest rates are inversely correlated. When one goes up, the other goes down. This is a really important thing. We're going to use this relationship over and over again. For example, when we talk about monetary policy. Jumping ahead a little bit, I'll give you an example. If I tell you that the Federal Reserve is going to sell $100 billion worth of Treasury bonds tomorrow, what does that mean will happen in the economy? Well, let's think about it. The Federal Reserve puts $100 billion of Treasury bonds out for sale. That means they're increasing. By the way, the Federal Reserve does not issue Treasury bonds. Treasury bonds are issued by the Treasury. Okay, so the Fed at some point has bought these Treasury bonds on the market and has been holding them. So back to my story. The Fed releases these Treasury bonds into the market trying to sell them. When you increase the supply of anything in a market, everything else equal, the market price will fall, right? You've increased supply in a massive way, so naturally the price of bonds, Treasury bonds, will fall. When the price of Treasury bonds fall, interest rates go up. So that's really important. This helps to explain why the Fed doesn't necessarily want to sell a lot of bonds in a short time. Not because there's a problem with selling the bonds. The problem is that by doing a big action in the bond market, you can cause the interest rate to move in a direction you don't want. So, inverse correlation, remember it, it's going to come back over and over again in the future. And the nice thing about this inverse correlation thing is it stays true in every context. So it will always be true, everything else equal, inverse correlation, bond prices and interest rates. So this last slide is a simple bit of data to illustrate exactly what I was saying. You notice there the purple line is the US 10-year bond price. So the purple line is a market price for a particular Treasury bond. The blue line is the yield. Now when we say yield, I won't get into what yield means exactly here. Just imagine it means interest rate. Okay? Blue line is the US 10-year bond interest rate. And by interest rate, I mean an interest rate that's determined by market forces. So what you see is when the price of bonds go down, the US 10-year bond yield goes up, the bond interest rate goes up, and when bond prices go up, the 10-year bond yield, that is the bond interest rate, goes down. So there is an inverse correlation between these things, just like we'd expect. Okay, see you next time.